Good evening. My name is Bram Vogelaar, or Bram in English, and today we'll be discussing, what happens when you want to have data in multiple data centers or multiple instances, as we had already discussed before. And I'll give you a teaser. My solution is slightly different than a federation. Perhaps you can discuss afterwards. So, yes. So who am I? As I said, I'm Bram. I used to be a molecular biologist, worked for some big pharma companies, big universities, and then, as my colleagues used to say, slowly slid down to the dark side, becoming a dev for bioinformatician, and eventually now, the last 10 years, really, I've been doing ops work. And currently, since the 1st of September, I am now a DevOps Cloud Engineer at the factory, a small consultancy company here in The Hague in the Netherlands. Yes, today was my first day at a customer, so it's a nice, great day to be able to talk to you about this. First of all, we should perhaps do a step back, especially since I've seen that people are new to Grafana. So when I say observability stack, what is that? So for me, observability is about knowing what your application does, what it's doing right now, what it should be doing. As an industry, we're pretty much on an agreement that means we need some form of metrics telling us, a value for something. We need to have logs and we need to have traces. So how long is an application doing something in a certain section, or even your microservices doing something in a certain section of your microservices infrastructure? If we put names to these constructs, then we're looking at Prometheus for metrics, or Thanos, Cortex, Timescale DB. In my world, we're looking at Loki, Grafana Loki for logs, and we're looking at Grafana Tempo for traces. How do we feed these things? Prometheus pulls stuff in from some form of exporter. We can push logs into Loki by, for instance, Promptail, and most of the time you'll be pushing traces into Tempo using a predefined SDK. And we can all visualize it in Grafana, and if we need to act on something that we are observing, we can use Prometheus's Alertmanager to send us alerts back to the users. That brings us to the 10th of March this year. Most of the time when I go to customers, they come back to us saying, oh, we have it all nice set up. We have at least 2 data centers for our application. But when we continue to ask, their observability stack or their monitoring stack is most of the time is only 1 data center. So why do I observe this literal container fire? This is what happened on the 10th of March this year. A big cloud provider in France, or DC provider in France, called OVH, lost an entire data center. Not just an entire data center, they lost an entire campus. So they lost 3 data centers. This was a big outage. And then actually the day after, my ISO 9001 person came back in and was like, have we fixed this? In our case, can we survive an entire campus burning down? That made me look into, can we turn this singleton of an observability stack into multiples? Of course, Tempo, Loki, you can actually run as a nicely microservices setup in and of itself, but most of the time with customers, I see it being run as a singleton, which is fine. But in the question we'll be answering today is, can we actually run multiple instances in multiple DCs, and can we lose at least one component, or can we lose the entire data center or campus and still have a view into what is going on? Of course, you'll see that half of your platform is down, or when only one service is down, you can actually still have observability into the data center while your observability stack happened to be down or component is down. So to reference another big failure this week, everything is a DNS problem. So the way I'm looking at solving the questions I posed so far is looking at, can we fix it? Basically, most of the time, yeah, using something DNS. And so I am now introducing into my observability stack a tool called Console. It's created by HashiCorp. It's mostly open source. There is a paid-for version available. And what it does, it's a service discovery tool. So basically, we can announce services into Console, and then you can query Console as a DNS server, basically asking, where is my service? It's also gained a key value store properties, which is actually what a distributed Loki or Tempo would use, and it has service mesh tooling built in, so we can do things as are people allowed to see my service? What services am I allowed to see? It's available at console.io if you're interested. And what would introducing Console into our service basically look like? So as I said, it uses the concept of services, and here I show a little JSON blob of how we could expose Grafana as a service, a Console service. Here, what you need to have a couple of things. You need to have a check, because Console has the notion of healthy versus sick services. And in this case, I have a simple HTTP check that goes to my localhost 3000 and checks if we get an HTTP 200 OK every 10 seconds. We name it Grafana, so that's also the service you can easily query a Console on. And in that case, we can query Console on our local port 8600 for something that's called grafana.services.console. And then you get an answer back, which we can use then to find our Grafana. You can easily incorporate the Console query, domain query into your local bind or unbound or whatever you're using. What actually is needed to get to the second data center is something called a prepared query, because Console only is built up in such a way that it's data center aware, but it prefers, well, actually it uses only your local data center for things like your key value store or where your services are, unless you specifically tell to Console setups to connect. In this case, we have connected DC1 and DC2, the clusters, and they are aware of each other, but they're not automatically a DNS query will go onto the other side. So for that, we need a prepared query, which is a simple, you can build those by having a simple JSON blob being posted to your Console server. And then basically I say, for the service Grafana, I want to make a prepared query called Grafana. Not very imaginative, but please follow me. And in case of a failure in my DC1, I want you to go into DC2 and request do your DNS request into DC2, and then point people into there, and it's going to be basically a pretty it's going to be failover that pretty much nobody notices, except for the time Console needs to work out that your services are down. So what would that look like if we go down the stack? We can have a simple query going into your Grafana. So if my Grafana goes down, I go to the other side, but the other side basically has nothing that the DC1 knows about, which means my users aren't there, my plugins aren't there, my dashboards aren't there. So I need to have some form of communication between the two Grafanas. Grafana has three sorts of database backends. It's SQLite, which does not scale, well, does not HA because it's a local file. It's basically a database on file. And then you will be left with two other options. It's either Postgres or MySQL. Postgres, I love it to bits, but has no open source master-master replication, so you're always stuck with some form of master-slave setup. So you'll always have one data center that's basically the primary, and the other one being the secondary, and you'll have lags in the data being written. So my preferred option is going good old Grafana from MySQL HA using master-master. So your Grafana will always be writing into the local MySQL, which is then replicated to the other side and vice versa. If we want to update our data sources, instead of pointing your data source into your local Loki or your local Prometheus, you actually use you update your data sources to use the prepared query we've built, which is actually nice. And then that's all you need for Grafana to, in case one of the data sources drops out, just go to the other side. Grafana, well, no, Prometheus doing HA, yeah, as weird as actually a nice introduction to what I'm discussing now is like, how do we do it? Do we do federation? Do we do, yeah, how do we do it? Do we multiple queries? Do we do, or do we read twice? Do we write twice? How do we do it? And in my case, I basically, since I'm proposing the following solution, basically Prometheus is a very nicely built in console service discovery option. So in this case, instead of having a long list of targets we need to scrape, I changed it to, in my DC1, I say, don't specify every target. I say we use our local console that is available on my local host. I want to look only at services that are announced in DC1, and anything that has a tag called metrics, I need to scrape it. And that way, everything that is in console that has the right tag is just automatically scraped into Prometheus, and from there you can build dashboards. And similarly, we can now also very easily scrape DC2 in the same way. It's basically copy paste of the little block, instead of data using data center 1, we use data center 2, and then we're scraping twice. So there is a bit of traffic going up and down between DC1 and DC2 now, but since it's basically text, the amount of volume over the line is actually not that much. How do we fix Loki? Well, Loki actually has a very nice built-in option to not write to one client, but basically write to 2 clients. So no, it's not Loki, it's Promptail, sorry. So you configure your local Promptail to push to 2 endpoints. One in DC1, one in DC2. So notice that I now use the IP addresses instead of the query, because I want to make sure that I actually write it twice. Well, then tempo actually was the most interesting one to fix. Well, fix air quotes was I asked the same questions. Should we send it twice? Which is actually not that feasible, since the available SDKs don't actually allow you to write it twice. Should we be writing twice? So sorry, I said writing and should have meant send it twice. So the SDKs normally can't actually send it twice, unless you start doing funky stuff with your code. So can we write it twice? So in the layer below, can we actually find a distributor or an ingester that could write it twice? The answer to that is no. Surprisingly, no. So Tempo and Loki, because they share an architecture, can use console, for instance, to announce themselves as individual services. But as we discussed before, console, you can only stay in your own data center. So it's the way Loki and Tempo uses console, you can never end up on the other side. So writing twice wasn't an option. Reading twice into Grafana, you'll end up with a similar story as we had already said. Like, we need to do either multiple queries, or we need to somehow aggregate it, the 2 instances. So that felt awkward as well. I never managed to really get it to work for Tempo. So my next thought was, do I need to create some form of a proxy somewhere? Gets a proxy somewhere that does the write twice. So actually, I had some half-baked Go code somewhere when Grafana, the lovely people at Grafana, came out with Grafana Agent. Grafana Agent actually had been around for a while. But in, I believe it was release 0.14, they actually added remote write for Tempo, basically making a Grafana agent a lovely proxy, exactly what I wanted to do. Grafana agent, people at Grafana, please correct me, originally was thought of an agent that could send stuff to Grafana Cloud. It perfectly works for as an agent to send stuff to your local Prometheus, your local Loki, your local Tempo. So in my setup, I'm now, instead of pushing directly to Tempo, I let all my tracing agents use a Grafana agent as an endpoint. And then basically I remote write into my Tempos. That requires a bit of a change. So my Grafana agent now has the receiver, in this case Zipkin, or there's others. There's Jaeger is the other big one, and now I write into two different endpoints, one in my local DC and one in the other DC. And then that makes us update our local Tempo config a bit. As I said, now the actual Zipkin receiver is in the agent, and we now want to be a receiver for the open telemetry data that the Grafana agent actually ships now, which makes it a different endpoint at a different port. So may also make sure that your firewalls are updated, which took me 2 hours of my life that I'd never get back when I implemented this. Turning the alert manager HA is actually absolutely simple. You started with an additional flag, basically saying I am a cluster and my peers live at the following IP address port. Then they start communicating, they start deduplicating alerts. And in Prometheus itself, you just need to add an extra target to your Prometheus .yaml file. Again, basically writing it twice, and then letting the alert manager cluster dedub it. So we're getting towards the end. So what would that look like now? Your observability stack. I haven't completely duplicated all the lines because that basically became one big hot mess of lines. So now I've added all the additional lines and components that we require to basically have a fully duplicated setup. So my Grafana, I added the HA MySQL, the master setup. I have an alert manager cluster, and my exporters are now scraped twice. My Promtail pushes twice, and my traces aren't pushed to Tempo directly anymore, but they're being pushed to Grafana agent, which now writes twice to both Tempos. And my Grafana can be found using the console query, which then actually uses another console query to find my data sources. Now I can basically kill any component or an entire data center, and I have still observability from another end automatically failed over. That is the actual end. If you want to contact me about stuff, you can email me. You can yell at me on Twitter at Attachment Genie. I'm basically Attachment Genie pretty much anywhere on the internet. My slides are already uploaded to SlideShare if you want to review them. And I have a Vagrant observability box where anything I discussed today is actually modeled in Puppet code. So if you want to find a starting point, you can use that. That brings it to you. Any questions?
Thank you, Bram. The person who had a question didn't yell at you because they were not using all caps, but let's go for it anyway. Bart asked, I'm assuming you chose for a console because of some services run as VMs. anyone ever did this using Istio multi-cluster in a fully containerized environment? And by anyone, we'll just say you. Did you ever do this?
Yes. I have used this in a containerized setup. Console is, as I said, has a service mesh functionality. It's actually based on Envoy, so it's not Istio. And basically, it can do anything that NVO can, but with a nice, easy-to-use HashiCorp source. So if you are willing to replace Istio with, well, a console, then that's the answer.
Awesome.
Which...
Thank you, Bram. There aren't any more questions. I mean, it's also getting late at our end, yes. Right? And we're getting towards the full half hour, I guess, that we said that we would end things on. So first of all, Bram, thank you so much for your talk and for joining us. Sam has posted a link to the survey in the chat, so please fill it out so that we can figure out how to improve these meetups and do better next time. I think one point of improvement for myself, at least, is if you have 5 talks, that takes a lot of time. You probably don't have any time for discussions later on, and we'll do better next time.